Hello. Alright. Man, this is my first real programming stream in a while. My first real one on this PC, so bear with me. What we're going to be coding is a man, how do I edit the full extension? There we go. Alright. So we're going to be creating a procedural ray traced starting and ending screen for the stream. I already had something like this before. Let me just switch over to the screen and show. Alright. This is what I had before for my stream ending. Basically like a dark night with clouds going by and stars. I want to do this a little bit better. So to begin, we're just going to open this up. We're going to use gedit. So here's the shader. Actually does the ray tracing right here for the clouds. And before I was using this little library to handle the WebGL setup, but this time I'm going to program it all in the HTML file, so these are kind of standalone. So that way I can easily copy this. So I'm just going to start by writing a little HTML file. Let me just make sure everything is working. All right. One sec. I want to see, does my typing show up in the mic? Okay. Well, I could increase the filter a little bit, or just not talk while it's typing. Yeah, it's not that bad, alright. Alright, so we're going to create our body, head. So in the head, it's going to do a title, stream ending, or actually stream WebGL scene. The body is just going to have a canvas where we're going to render, and then the head is going to have the actual script here. And we're actually going to want a style where we disable any of the other styles. Man, I gotta get a silent keyboard, or one that doesn't click clack like this. Like, man. Yeah, that tab is way too big. zero margin, zero padding. So our canvas has nothing around it. I'm going to add an event listener, the DOM content loaded. So this will call this JavaScript function when the page is loaded. And then we can do our initialization for the canvas and everything. So CLE, it's going to be short for C element. It's going to be our canvas element. We get elements by tag name, canvas, and we'll get the first canvas because that's the only canvas we have. We're going to do a fixed width and height. I'm not sure what resolution I'm going to do yet. Let's just do 1280 by 720, even though that's probably not going to fit. And then we're going to get the WebGL context. So we do canvas element, get context WebGL. And we're just going to use, man, actually, do we want to use WebGL 2? We can use WebGL 2, because we can always just update our browsers now. And we're just going to throw an error. In case it can't load WebGL, because this could always happen if there's some issue with the graphics card. The display driver crashes or something like that. It would be stupid to just not throw an error here and have it just show a blank screen and have you wondering what's going on. Alright, so now that we have all this, so we can do request animation frame, or we can do set timeout or set interval to render at our own rate. I'm not sure if I want to render at full 60 frames per second. Especially if I'm doing ray tracing, that might be a bit expensive, but let's try it. That's the animation frame. We're going to create our render function. So what we're going to do here is we're just going to request another animation frame at the end of this, so that we calls render over and over again. And then GL here that has our WebGL context. We're going to do WebGL. We're going to do GL clear color, set the clear color to green, just to go green, say we're good to go. Do clear color buffer bit. So this should clear the canvas to green. There we go. So there we go, that's using WebGL to render the background to green. And yeah, like I said before, this isn't going to fit unless you do full screen. Window bar and taskbar takes up so much space. So I'm going to scale this down a little bit. I'm not sure. I'm not sure what would scale down well. Let's try it. 0.8. Yeah, that's a weird number, but it works. Okay. I want to try and maybe get it perfect so it takes up much space as possible. I'll just do this to start. Screw it. While we have the calculator open, I could use math to actually calculate the perfect value, but trial and error works. Oh, okay. That's basically perfect. As much space. Okay. So now what we're going to be trying to do is we're going to render a shader. So I was going to look at this old JavaScript file I had here, functions for loading shaders and stuff like that. But I did a lot of complicated stuff where I parsed extra things in the shader. I think I'm going to keep it really simple this time. I'm just going to create a function for creating shader. And it's just going to have an option for vertex or fragment. So how this is going to work is we're going to create a new shader with GL create shader. And if it's a fragment shader, we'll do it like this or like that. I think that's the only time we have to do it. Let's just look here. Create shader, protect shader, fragment shader. Yeah, okay. We gotta do shader source, compile shader. I'll just copy this, because this is the exact part we need. I'm so paranoid. Is this showing up on the mic? Oh my god, it isn't. Dude. This noise filter is actually great. Hell yes. Okay. Alright, compile shader. And we just need the same code where it checks compiled correctly, and if not, it's going to output to the console the error. Okay, so I'll create a new shader. We can go and initialize our shader here. We'll also need to create a program or link a program with both those. You can see right here attaching a shader. We'll need to get uniform locations. We'll also actually need to bind attribute locations, I believe. Alright, so an easy way of including the shader, we're just going to start writing our shaders quickly just to get started. An easy way to write the shaders in an HTML file like this, including the JavaScript, is just to create a fake type or a fake text type like GLSL or something. Like vertex shader, and then given an ID that you can easily access it on. I'm going to do full screen vertex, FSV for full screen vertex. I believe it's 300 ES, version 300 ES. Yep. Okay. So what we want to do is we want to define ES, and do precision high P float, precision high P int. Also, this isn't going to get highlighting right now. If I want highlighting, I can go to OpenGL shading like this. That's better. Alright, so now the shader enters in the function void main. Leave in WebGL2, yeah, it needs to define its own output frag color. Or actually, if this is a vertex, I can just do it own, or I can do it as I write it. I actually need to do this full screen quad to lay out the attributes first. I think GL position is still, with GL2 you don't need to define it. So MEP is going to be, or I don't know if I'm going to do in position, input position. While I'm looking here, I should do all of these as well to set up WebGL and OpenGL correctly. Active texture 0, disable blending, offset fill, cull face. Actually, I do want to enable culling face. We want to disable depth test. Clear depth, clear color. All right. Then I'm going to write the fragment shader now. You know what, looking at this, I can actually include that just automatically. Right here I can do source. I can tack on like this. That should work. Alright. So actually I'm going to output a value here, an attribute, UV. That's going to be equal to the in position centered. And then what we're going to do in our fragment shader here, get our invec2 UV, and in the frag color, the output, we're going to output UV. And then I'm just going to call this UV to start, because I don't know what this shader is actually going to be. I'm just using this to test setting this up. All right, so let's test compiling these. Now I'm getting this element, reading the inner HTML from it, and then I'm actually just going to feed that straight into the create shader function. Do the same with the UV, and I'm guessing this is actually going to throw errors. So I'm just going to run this right now. Create shader is not defined. Oh, new shader. Get shader parameter is not an object. Oh, oops. Supposed to be S, not source. Error compiling shader. GL color undefined. Okay. Yeah, oops. So this is what I'm supposed to do here. Or what I can do to make this a lot easier is I can do like how I tack this onto source like that. I can do if this is a fragment shader, then I can add on what would it be, out vec4 frag color. Source. Okay. So then actually, instead of doing GL frag color here, I just want to do frag color. And it actually compiled. Okay. So now we're going to create a program. This is going to link our vertex and fragment shaders into a full shader program. I think that's how it goes. Oh yeah, and I also need to bind attribute locations. The mesh. All right. And then get program parameter in case there's errors. Error linking shaders. Okay. All right, I'll create our new shader program. We will use this program like this. Program. Oh yeah, and then we need our full screen quad. Oh yeah. Hey Mormay, three stream per day. Yeah, it's all over the place right now. I actually remembered the most efficient way is actually to render one triangle, and just to make it bigger than the screen. Forgot about that. So what I'm going to do is, how am I going to do this? Quad, I don't know, mesh. Mesh is gl dot, oh wait, am I going to need to use vertex buffers? Buffer, bind buffer. Oh wait, no, sorry, I didn't mean vertex buffers. I actually meant vertex array objects. I don't need to use that. I can just use a vertex buffer. Alright, so now instead of 3D coordinates as well, I just need 2D coordinates. Okay, so where should my triangle coordinates be to completely fill this screen? I'll do one in the bottom left corner. I also need to make sure it follows the proper winding order. I'll disable cull face just to test at the beginning. Alright, the first one will be -1, -1, so the bottom left corner. And if we're doing counterclockwise, then the next one should be to the right. We'll do 1, 1. And then this one should be up above, very high. Okay, this can be 4, 4. And this can be -1, 4. And that should do it. Wait, actually that should be 4, -4. Okay. Alright, so basically I'm trying to make a triangle that fills up the full view. Okay, yeah, and then I can call vertex attribute pointer, set this up. Alright, I do not remember the vertex attribute pointer. I don't remember what these arguments are. Offset in bytes between the beginning of consecutive attributes. Zero, I think. Stride is 0. This one would be tightly packed. Okay, 0. And then I gotta do gl.enable vertex attribute array. Alright, oh man. Just opened Twitter and today we've released Vulkan API 1.2 spec. Adds 23 extensions. Huh. Is that... So do each of those extensions have their own little API? Oh man. Alright, so now that all of this is binded, I actually should just be able to call draw arrays. Triangle, and I just need to draw 3, or actually just GL triangles. So let's see if this works and compiles. Current program is not linked. Okay. There's like this green thing on the side here. Can you guys see this? Is this showing up? It is. Why is there like a green... I'm closing this and reopening it. Vulkan has too much and not enough. No one uses it. Day by day, it becomes something big, and no one knows how it works. That's what I see it. I got a lot of people are looking at it and considering it, and they're just waiting for like. If they're like me, they're just. They basically, it's not something I need. That's basically what it is for me. I'm like getting by with OpenGL, and when I look at doing Vulkan, it's basically like I don't need all of this complicated stuff, and the improvements it gives like aren't really worth all the extra work it takes to implement it for me. So this wasn't linked. Program, link program. Almost finished my Vulkan framework. I love how simple Vulkan is. Much better than OpenGL. Okay, man, I do not think Vulkan is much simpler than OpenGL. Like, I think it's the complete opposite. It takes like much more code to do the simplest things. Adding new features to Vulkan is much simpler than an OpenGL engine. I think it depends what features. I mean, if you're just doing like normal triangle rendering like I am, and just trying to operate on some pixels on the screen, then like GL does everything you need. I wonder if I have to call use program again or something. My simpler framework that renders just framework. Render just frame buffers, 10k lines of code. Nice. I'm honestly not sure if that's good or bad. Depends what stuff you're doing with frame buffers. Do I have any draw calls here? I guess I don't. Oh my god, I'm stupid. I'm not returning the program here. Holy shit. Oh, that took too long. There we go. Okay, so the triangle isn't quite big enough. You can see the triangle clipping there. Let's actually calculate this. Here we can see the triangle going to each corner. I believe you would need to make the triangle infinitely large, cover here. But I think, so I gotta think about this. I believe the scan lines go horizontal. So if you have extra space up above or below on the vertical axis, it'll be clipped more efficiently than extra space on the horizontal because it does horizontal scan lines. So then I want to make it taller, longer. I mean, it's simple to add something new. Super simple, add model viewer or in IMGUI to my framework, just adding new logic. When in OpenGL engine to add some new, need to rewrite old. I don't think that's true for every OpenGL engine. I think that depends on how you write your OpenGL engine. Alright, so if this is 10% over here, can I get it above just by doing 0.1? I think that's good. Oh yeah, okay. Let me make this all black just to make it way easier to see. That way I can see if it's actually clipping at the corner. No, it's not. It's perfect. Okay. There we go. We've got a full screen triangle that's rendering at like maximum efficiency. So now all we need to do, okay, actually this isn't all we need to do. So right now we could start doing basic ray tracing. We can turn this UV coordinate to that, but we need a few more things. First of all, we need time. So there's a few things I did in this old one that I want to do as well. These are random variables. Where did I do these here? Okay, they're actually not right here. What I did was, though, is I loaded in random variables based on the time so that it could randomize these each time. And I also need to feed in other variables like the time. And since the screen aspect is fixed, I should actually just be able to do all that in the shader. But yeah, and then I also want to do a frame buffer so that I can feed back in to each other and then reuse the same frames over again to do some temporal effects. In my shaders, even for Godot, I copy shader toy uniforms. Ah, okay. Basic logic for every shaders. Yeah, I mean, it has all the resolution and time stuff. I'm like super obsessive about optimization. I don't include anything unless it's needed. I'm just thinking what I want to do first. I think I'm just going to do these random variables to begin. So the way I did these is like this. Actually, yeah, so basically, let me figure out how to write this. I guess we'll create a function that applies it. So it basically loops through and applies replaces a certain number of instances of the random values. So got like do index of random like that. And then of course, if it doesn't find any right now, it's done, so you just break or return. But then if it does, oh wait, actually, so you replace this with n. And then if it does, oh wait. I'm also going to need to replace this, so I need to know the length. So I'm going to put all this in a string so that I can just do string.length. Alright, so then now that we know there's this random instance here, there's not a replace in my cat just opened my door. Okay. I think I have to use splice. Wait. JavaScript string replace. Am I stupid? There's actually a replace function, isn't there? Oh my god, okay, wait. I can just call this and do source equals source.replace. Replace this instance of that with an actual random value from 0 to 1. So now we can do like ran0, ran1, ran2. I'm going to apply this. So the fragment shader there. And it has an error. Undefined. What did I do? Oh, I'm supposed to return after this. Alright, here we go. So this will generate a random color each time. And not just a random color, but any random value I want, so that each time I start this up, it'll do something different, which I think is a really nice feature to have. By the way, you use WebGL 1 or 2. I'm using WebGL 2 for this, just because I think every browser from now on is going to support it from what I've seen. So there's no reason not to. And I'm only going to run this on desktop where I'm streaming, so should be supported everywhere. Hold on, one sec. Let me test something. How much of my typing shows up in the stream? I'm trying to fix that. It's so hard with mechanical keyboard. On one hand, this is like the best thing for me to type on. Like, I love typing on these. I don't want to get a silent keyboard just to make the stream good, because I personally love typing on this noisy, clacky keyboard. But like, I actually almost think I've got it where the noise gate is catching most of the key clicks and stuff. Like right here, like smashing the keyboard. Oh man. Anyways, you can see here, WebGL2. It's fine for me. Alright. Anyways, let's try enabling cull face now. See if it's oh, okay. I got it. I got the triangle ordering correct. So now I want to feed in the time. That's the one other thing I need. So we're going to get a uniform location. So I don't know if I want to. I'm just uniform, uni. GL get uniform location. I haven't done this for a while. I think it's. Oh, hey Donho, I haven't seen you for a while. I won't worry about it. Your mic picks up enough background noise to dampen it. Oh god, there's like no background noise going on other than the keyboard clicking though. So I'm just going to feed any uniform variables I need into a giant array because that's what's most efficient. I don't know what I'm going to call this. I think I'm just going to call it UD. So uniform vec4 UD. I'm also thinking I might feed in integer data, because one of the issues I had before was when the time float got super large, it ran into floating point precision issues. But I feel like if I feed in an integer, it would be way better, because I can just like do anything I want to it there before I convert it to a float, so it doesn't run into the issues. Like I could make it loop. I'm not sure. I'm just going to use floats to begin, because that's what's easiest. Too much adulting. Monkey face. Well, I'm glad you're back. And I am going to make this an array just in case I want to add any other variables. So then when I call this here, do GL uniform for FB. And then I'm going to need to feed in the floating point data, and we're going to put this in a floating point buffer. Or we need to make a new float 32 array for this. And then we can feed in, set the first one of these float values to the time. Also make it loop after 100,000 so that it doesn't have giant precision issues. And then to test it, I'm going to output a sine wave right here. Oh wait, also, I forgot, I have to set up options. If I want everything to work absolutely properly, I need to set up options in the canvas here. And I get the context like this. Set alpha to false, depth to true if I want depth, anti-aliasing to false. I believe there's also an option to say if you want to use GPU accelerated rendering. Anyways, we're feeding the time into a sine wave here. Interesting. Why is this outputting red and blue? Outputting a vec4. Oh, wait. That's why. ud.x. Here we go. Okay, so the time is working perfectly now. Feeding in the time. This light flashing on and off is the sine wave value going up and down. So we're set to go now. Actually, one more thing, but I think I might do that after I start doing some ray tracing, and that's creating a frame buffer so that I can do a feedback effect of feeding back in the same values. Yeah, screw it. I'll just do the feedback effect right now. So we're going to create a... actually, that sine wave, if I make it into an actual like wave, it would be good for a feedback effect. So we're going to do the distance from the sine to the y. And we're actually going to use the UV from -1 to 1 now. Alright, actually we're going to do 2 UVs. So the first UV is going to be centered with no aspect ratio. The other UV here is going to be scaled by this aspect ratio, which is 1.7777. So then we can use that for our okay, so actually this is going to be uv.x plus the time. So it's basically going to be a line that goes up and down over time. The absolute value, that difference between the y oops, there's errors in both shaders. Oh, I'm dumb. This is supposed to be in position. I'm multiplying UV by itself. There we go. So that's a very smooth sine wave, as you can see. We can make it sharper by multiplying this. So there we go. Okay. Make it go a bit faster. Or I guess make it and just all around make it higher frequency. Alright, now create a frame buffer with background. So I'd go over. I haven't made a frame buffer for a while. I need to make a texture. I need to attach that to the frame buffer. I'm not doing any depth testing, so I don't need a render buffer. The FBT is going to be our frame buffer texture. And I think you call text image 2D like this, if I remember correctly, to set the size. Oh yeah, and the format. So I'm gonna use 32-bit floating point format, I think. Hey, said who? I'm just thinking though, I don't want to do some insanely complicated rendering chain. I'm thinking I'm just going to keep it super simple and just do 8-bit feedback. Not do some floating point texture with 32-bit precision. And Alright, I just add this to the frame buffer. Is it frame buffer? No, it's just frame buffer, isn't it? Not even frame buffer 2D. Does it not also reference the functions here for color, hatch? What function is it for? Wait. Oh, is it frame buffer text texture 2D? Yeah. That took me a bit to remember. Alright, then I just need color attachment 0. Wait, I thought it just... Weird, I have to say what texture target it is. And what texture object it is. It should be able to just get the texture from the target. I don't know. Maybe this was like a WebGL function where they didn't go with the normal OpenGL state machine way. I don't know. All right. Oh yeah, then the actual texture object. Okay. So that now should render to the frame buffer, and it shouldn't render anything on the screen. No texture is bound to this target. Oh my god, I binded null. What am I doing? There we go. Okay. So then, this is actually an awesome... Wait. Does WebGL2 have blit or draw frame buffer? Oh, it does! Yes. So this way I won't need another shader just for copying my frame buffer onto the screen. I can just call it blit frame buffer. Okay, so let's set this up. So just to be clear, I should actually call this draw frame buffer just so that it's like clear all through the program. It did say in that other part that draw frame buffer was equal to frame buffer, didn't it? GL draw frame buffer. Oh yeah, draw frame buffer equivalent to GL frame buffer. Alright, so that'll draw to there. Then it'll switch that over to the read frame buffer. And it will set the draw frame buffer to the screen, which is null. And then it'll call blip frame buffer. Of course, X, Y. So the rectangle, alright. Just copying the exact same thing, so just like this, 0, 0, width and height. And there we go, that actually should do it. That should hopefully render to a frame buffer, then render to the screen. Bad target none, frame buffer is not complete. Oh, I spelled draw with a lowercase w. Requires at least 8 arguments. Oh, I forgot about the mask. There we go. Okay, so that renders to a frame buffer, and then it blits that frame buffer to the screen. You can't write the same frame buffer you're drawing to, so I'm actually going to need to create 2 of these. I forgot about that because I'm an idiot. So what I probably should have done is created a function for creating these, and then I only need to call this code once. Oh, and I just need the frame buffer. I don't actually need the frame buffer texture. Oh wait, I do. I'm reading it. How do I want to output this? I guess I'll just put it in a mini array together. And now I should just be able to do new FBO. So since it's an array, I'll read 0. Oh yeah, okay. And then if we're going to input this, we need a uniform sampler 2D buffer. We're going to create a UTI. Oh god, yeah. Oh man, no, that's a bad variable name. Too late now though. Alright. Uniform location. So now right here we're gonna bind texture of the, we're going to bind the texture of the second frame buffer that we drew to last time, or we rendered to last time. And then we're going to call uniform 1i to load that in. Okay. Then after this, we need to swap the frame buffers. So we store them in a temporary variable, and then we swap them like that. There we go. So now, okay, actually there's one more thing. The frame buffers won't be initialized. It might have broken data at the beginning. So what I'm going to do is I'm just going to do GL clear. Like that, just to make sure it's initialized to black. And there we go. Now we're going to sample the buffer. And we're going to mix it with this current frame. Create a blur effect. And hopefully this will work. Draw arrays texture 2D at unit 0 is incomplete. Okay, I'm doing this wrong. Bad bitmap dimension or format. Oh yeah, what filter do I have on this texture? Text I. Bitmap dimension, you know about power of 2 rule? Yeah, it doesn't apply to frame buffers. Actually, it doesn't even really apply anymore. It's just more optimal. You sure? Oh yeah, for bitmaps. For bitmaps, there's a few platforms that still don't support non-power of 2 bitmaps, but most platforms do support. I know that because in the last WebGL thing I made, Marbles Race, I calculated the average brightness of the screen using bitmaps, and I could easily do it. It just worked with a non-power of 2. Alright, so hopefully this will... Here we go. So now this is applying a blur. It's very hard to see. Maybe if I increase it a whole bunch. Anyways, now we have a feedback effect. As you can kind of see, blurs over time. And this is everything we need now to do our Raytrace shader. And so the whole reason I had this whole thing before this, like 50 kilobyte, 2000 line JavaScript file that did this frame buffer stuff. And I'm really obsessive, and that just kind of bugged me. So that's what we went through and did today, is we went and reprogrammed it. So now we just have these small new shader functions and it's a small 150 line HTML file that has no extra add-on files. So it's like, if you compare this, I had to copy a bunch of these files before. Now I just have a single file that just runs on its own, which is very nice. So now what we're going to do is we're going to copy over this shader. Or actually, we're going to fix it up. We're going to start with the stars. And then we're going to fix up the clouds and all of that. I'm going to go and get some water in a sec though. Working on SIMD for your engine. Nice. Who thought just simple adding and multiplying instructions could be so fun? I'm just going to copy this stars function to begin. And I'm not sure what the stars even look like. This returns a VEC4. I didn't realize that, so I guess that means it, I designed it to work with colors. I forgot about this. So I did fake 3D for this, it looks like. Why? Yeah, it looks like I did fake 3D for these stars. It's not... What is this S it's feeding in? So the scale... Okay, I gotta test this out. So that's the scale. I'm gonna initialize this to 0. Oh, there we go. And it looks like the random pattern isn't bad, actually. It does look like the hash has issues, though. You can see lines along here. I'm going to try keeping this initial part. What is up with those lines? You see how it's setting up RD here. Wait. Do dot XZY here. Oh, there we go. Hey, we've got stars. Huh. Would you look at that? Okay. There's our stars. So what we're going to try to do now is we're going to make them change colors each time. And we're going to try and make them move. So I did do something to program these to move last time. What did I do? I rotated also wanted to do random sampling here to smooth it out. Anyways, I'll do these random colors first. So right here where I multiply this sine wave, this should actually affect everything. Changing this should change all the colors. Yeah, so let's change this to rand. That, and bam, got random star colors. There we go. Each time the stars, the layers of them change colors. I think that's pretty nice. So now we're going to add ray traced clouds to it. Also, I want to add some movement, but I'm not completely sure how. I'm thinking I might add slight rotation. Doing a little rotation like this one did. Ooh, there's something that's happening there. Huh, what is that? I'm gonna try extending these instead. Whoa. Yeah, so I think rotating is the way to go, but why is it doing what's happening here? Let me slow this down and think. I think that's this one right here. Let me see. No, yeah, it's totally that one. Oh, that looks so good though. Very happy with this so far. Something with this first. Oh man, I don't know why it's scaling up like that. the XYZ plus 0.2. Alright, let me see if I can just get the same effect just with this constant. Alright, yeah, so I'm just going to do a constant random background here. Here, where I apply random, I want to apply 6 now. And I probably want to do more blue colors. I don't want to do all these different red, green. Alright, that's looking like it's pretty good. I am liking those colors, so now we're going to want to do the clouds. It's going to be the... So this ray traces through, or I guess it's technically called ray marking, through some layers of stars to generate these. So each of those different colors is a different layer of different sized stars. And the background and those star colors change each time. I'm really happy with the way this looks so far. Now we're going to do some stochastic volumetric ray tracing, which is going to be might be a bit difficult to get right. We'll see. And we're also going to we're going to get all this working with some temporal. Basically, we're going to add up frames over time so it doesn't look noisy, or we're going to hide errors with blurring. But I'm going to get up and take a break 1 second. I'll be right back. Alright. Wait. Hold on a second. I actually think I just leaked something. I'm not sure though. I'm pretty sure the shitty quality of my stream, the encoding might have hidden it. No, it's fine. Alright. So going and looking at this cloud ray tracing right here, just does some decently quick steps through these clouds. It looks like it's just, oh yeah, I use this water effect to distort it. We're gonna set up our ray position. And I think I can just advance the ray position so that it's automatically up at the cloud plane. Like if I have the clouds starting at like 4 divided by rd.y. I'm not going to do any colored clouds, they're just going to be black and white. L is going to be our lighting multiplier. I'm going to do the same thing as here, where I just do 8 steps through the clouds, so it should be very cheap. And you know what, screw it. I'm just going to copy the same distance function here. Alright, there we go. So now, let's try doing the value as L times sky. Oh yeah, and we need to scatter the ray direction. Which I do right there. Okay. Selection requires structure or interface block. What line is that on? 42? Oh, this is UD, not UV. There we go. So those are our clouds, those dark blotches. That noise is ray tracing. That's why we're going to need to apply a blur. And also, we're going to apply a little hash to this so there's anti-aliasing on the stars. And then how am I going to do movement? Wait, so how far do these clouds go? 6. Is it going all the way up there? Okay, I'm gonna add the buffer now just so that it's clearer. There we go. And the twinkling is actually a kind of nice effect. Alright, so now I've got to work on these clouds, making them a bit softer, making them move. Alright, so that is working. I want to make the clouds a bit more transparent. Should be able to do this right here. So that adds some more shading. Probably going to go with that. That adds some nice shading there. Still want them to be less see-through though. I think what I can do is do times. Actually, doing multiply here should make it more, yeah, more fuzzy, and then doing times 2 should make them smaller. Yep. And then doing disk times disk should be a different, be smoother. I want to try and get them less see-through. That's not quite enough. I did plus. Or minus. This should be making the clouds smaller. Oh, yeah, there. Actually try this, max 4 and minus 0.4, so that it starts there. Yeah, that does give more detail. Interesting how it even looks different the more samples you get. Yeah, there's a way to fix this. I can't remember what it is. I think, so from the buffer here, I think you subtract a tiny constant amount. Because the precision is this, you subtract that. Oh yeah, and then max 0. Did it not compile? Didn't compile, did it? So you can see over time the colors here kind of get washed out. Actually, it shows up more right here. Sort of lazy shading. I think that does fix it. And you know what? I'm pretty happy with how that looks. I just want to get it moving. I think if I just do... Okay, where did they go? Oh, I'm doing it on the y-axis. It's supposed to just be the x and z. Oh, yep, they're moving. Slowly, but they're moving. There we go. Alright. I want to try to randomly seed the clouds. I think literally just feeding in this random seed here, just feeding in random values right here, should probably do it. Let me just get the movement all randomized and everything. The movement right here along the X and Z. I think I'm also going to do a random base movement. So that's going to be like up to negative 10,000 backwards. And then it's going to move randomly forwards. Actually, or in a random direction, I'm not sure. Yeah, you know what? I'm just going to start in the center and just move in a random direction. Yep, so each time moves in a random direction. There we go. So then what I also want it to do is to randomize the clouds a little bit each time. What I'm going to do is right here, as the vec4, I'm going to multiply these by some random values. Syntax error. What is that? String contains illegal character. What is bugging out there? Something about the longer random 10 here. I just realized I should convert these to strings. Legal character. What is happening here? Whatever it is, it's with this random 10. Alright, that is weird. Oh, I'm dumb. I remember now why I needed this this sign at the end. So that it doesn't confuse rand 1 and rand 10. There we go. Alright, so now the clouds are pretty much different each time. Now the one thing I want to do is different intensity of clouds. I want some clouds to be lighter and some clouds to be darker. I want some clouds to be more bright than others. So we're going to change the brightness here. This will give us different brightness of clouds. Then I'm going to do different odds of hitting the clouds, which will change the opacity. Lower being darker and higher value being lighter. That also makes our clouds look different. Now, I also think I want to try and do something to make some of them bigger and fluffier. I can't think of any way of doing that other than changing this scaling right here. Cloud scale. I'm going to see if I can easily change this. So does this make the clouds thicker? It does. Okay, that's cool. I'm going to randomize this as well. Checking which random value am I on right now. 12. Oh no, 12 and 13 are down here, so I'm on 14. There we go, that'll give us some thicker clouds than others. Now we're going to try changing the cloud scale. Oh yeah, so this gives us big ass clouds that are like 50 units big. And this should give us small clouds that are like 2 units big. Oh yeah, that's awesome. Okay, now we're going to randomize this. So this goes between anywhere from 1 to, we'll do 40 units big. Actually, we'll do 25. So there we go. Sometimes we get small clouds, sometimes we get big clouds. Let's add the movement back in. I might make the movement a bit slower. Different. We're gonna make it a bit clearer now as well. A bit smoother. Lower the movement a bit. Wondering. I might do them faster, but then I might scale it so on average they don't move as fast. That makes sense. A few times you do get them moving fast. You know what, that's alright. That's quick enough. And then we're going to add a very, very slight rotation. Because this makes it look crazy. Oh my god. Okay, I haven't tried that for a bit. That actually looks so cool. Oh my god, I'm very happy with this. I think I might actually be clipping into the clouds. Sometimes we'll see. Oh yeah, it's definitely starting in the clouds right there. Alright, I'll start 4 units up like that. That's pretty good. Still need to do less rotation. Okay, so this shows the big problem where moving things never disappear. They leave this trail. Let's see if we can't get rid of this. Can't tell if that's better or... I don't think that does anything for it. I'm going to try and compensate for it. If I can't, it's no big deal. Yeah, I don't think I'm going to be able to compensate for it. Either way, I'm pretty happy with how this looks. Let me get this set up. And now I need to crop this. It fits. Disable this while I do that. Man, editing these transforms in OBS is like, you have to edit the values exactly. It's actually hard to see when it's selected because OBS the border is hidden by the OBS selection border. I can't set that to 0. There we go. Okay, so that's weird. It's showing... Wait, is it just me? Okay, what was that? It seemed like it was showing a height of bounds. Alright, I need to calculate this exactly. I feel like I should actually go into JavaScript and calculate these exact values. Wait, is that it? That actually looks perfect. Oh my god. Oh wait, there's a little border. So wait, I should actually be able to calculate this. Hold on. 1366 minus 1024, 342. Oh, 1152. 214. Oh, it was so close. Look at this. 215. I literally almost found it. Okay. I think. So then the issue here with the bottom is based on the taskbar and all this. So what I think I can do is canvas element dot left offset top. JavaScript get taskbar size. Get mean. Oh, get bound and client rect. No, that doesn't have what I'm looking for. Shit. Window. Get. Huh. Get on screen. Script. Get size of search bar. I don't know what to call this. The top search bar. Window offset. Can't believe how hard this is. Oh my god, is it really just screen X and Y? No. Negative X, negative Y. Screen X and Y no longer work. Yeah, that's wrong. Oh my god. I guess I have to manually calculate the distance from the top? Oh my god. How, wait, what? JavaScript, get position of element on screen. To screen. Oh my god, is there actually no way to get the size of this top area? Holy shit. Yeah, this doesn't work? Oh my god, the state of JavaScript in 2019 in browsers is a fucking mess. You can't even get the positions element on a screen efficiently. Oh my god. Right, so I guess I'm going to be manually calculating this. Well, I'm not going to manually calculate it. I'm going to go into paint.net and I'm going to fucking figure this out by measuring it. Holy shit, though. This is why I don't use JavaScript to make games or anything. It's a disaster. Alright. 73. '74 actually. Okay. Top is 74. Bottom should be I guess I'll measure that as well. Six. Okay, that's obviously not right because it has Yeah, that is not correct. It's showing, I think this is, yeah, wait, the top, wait, where is it measuring from? It's capturing all of that. So then it should be 74. Why is there still... Why is there still a little gray area up there? If this, like measuring this is 74 pixels. Like, look at this, 74, 74, that's the vertical. So top should be 74 or 73 down, right here. What is going on in OBS? Oh god. Wait, what the fuck? What is this? What is there? What are these white areas above and below? Dude, is OBS bugging out? Reset transform. Let's reset this again. What are these white areas? Like, actually, what the fuck? Hold on. What is this? What is happening with these white areas right here, where if I go not minimized, they if I don't go from full screen, they disappear? What? They're gone now. What? What the hell? So look at this, if I go full screen, these white bars above and below show up on the window capture. What the hell? They're super small, but they mess up the framing. They mess up the cropping of the of it. What the fuck? Man, there's some stuff in software like this that just drives me fucking crazy. Like, are you serious? Let me just try deleting this. I'm just gonna try deleting it. I have multiple instances of this, so I'm just gonna delete it. Oh my god. Man, it just drives me so fucking crazy when someone else's software has bugs in it. Because I know there's, like I've said before, there's just no chance that I'm ever gonna fix these bugs. I'm basically just stuck with it. Okay. I have deleted all references. All the references to it. So now, try adding a brand new window capture. Capture Firefox. My window title. Don't capture cursor. Oh my god, what are these bars at the top and bottom? Seriously, what is this? What the fuck? Okay. I guess we're just dealing with this. There's some of this stuff that's just so incredibly stupid. GLM is so complicated. Math is complicated. Dude, I'm actually fucking dumbfounded. What are these white bars? Files like setup.hpp. I mean, everyone has their own way of doing things. Wait, now there's... Why are there black bars on the side? What in the fuck? Look at those there's tiny black bars on the side of this shit. What the fuck? Oh my god, I got it. Oh my god. Wait, no, there's... Are you kidding me? There's still little black bars. Oh my god. Dude, I gotta be honest. OBS is not... Like, OBS is the fucking equivalent of Blender when it comes to UI and, like, usability. Like, it is not user-friendly. Holy shit, having to manually edit this cropping value by value, and the fact that I'm cropping the edges, so you can't see this on my screen because of like the way I have to edit it here, but in the actual OBS window, it puts a red outline. You can make it fit to screen. Yeah, the issue is I have to crop the inner window. Yeah, I have it fitting to screen. The issue is the cropping. See right here? Oh, it's got extra stuff on the edge that I need to cut off. And you need to get it exactly pixel perfect. Otherwise, there's these little white edges and black edges around the border. And then, like I was showing, it for some reason put in a white border at the top when there's not even a white border in the window capture. It doesn't make any fucking sense. But yeah, you have to edit it pixel by pixel, and you have to look at the actual border to see if there's any pixels showing. Except when you have the object selected in OBS, it puts a red border around the edges exactly where you're looking to see if there's pixels. So I need to change the cropping, deselect the object so that it hides the outline. Oh man. I think I got it though. Holy shit, are you kidding me? It doesn't save the cropping between scenes. Oh my god, that's so triggering. I need to do the cropping again for this second. Oh my god. If you duplicate objects, it doesn't save the cropping. Oh my god. Fuck. Let me look at these exact values. What the fuck? Man, OBS is so bugged sometimes. I just opened this shit and it just lost the window. Like, what? Wait. What the fuck? The window literally just disappeared from the window selected, wasn't showing up under the list of windows. Okay. Alright. Copied the exact cropping values, so it's good. Oh my god, okay. Holy shit, I got it. That took way too long. Oh, wait, I maybe need to add it here. Nah. Started writing SIMD, but I think I should wait for that, instead focus on completeness, because this is just not that simple. Yeah, it is not simple at all. Like, that's the huge issue with it, and why a whole bunch of devs have... I don't know if you've seen games like Apex Legends have been coming out where you literally can't play it unless you have SSE, a processor that supports SSE. I think that's ridiculous, but that just says that even like devs at EA have such an issue programming with this, where they choose to only program it with SSE. But basically, yeah, it is complicated. You literally need to... I think it's the opposite. You do need to take it into account from the beginning of the development, because of stuff like memory alignment. You need to have your vectors in aligned memory. So you literally need to have that stuff planned from the get-go. That's why I don't think it's something you can just add on afterwards. Anyways, that'll be for Vec 3, like, how do you do it? Normally people just don't use the fourth component. You just use Vec 4, or you use a 4 vector, and then you just don't use the W component for something. That's the thing, is if you don't have data that is aligned, then you basically either gotta waste some data aligning it, or waste some processing power aligning it, or... I'm making one more change to this changing how quick it rotates around. Alright. That'll be the stream for now. What is... Okay, never mind. Man, I have not done a I haven't done GLSL shader programming on stream for like a while now. I'm happy to do this. I'm actually might come back tonight and do a different shader. Otherwise, I'll be back tomorrow, do another shader programming stream. This stuff is so good for my brain, just going through and like calculating this stuff. Yeah, all the various ways that you can use SIMD is what makes it so difficult. Yeah, SSE, SS3, AVX. So that's part of what got me about the Apex Legends thing, is right now nearly all the new processors support AVX, even AVX 512. So I thought that was super interesting that the Apex Legends devs decided to go for SSE3, which isn't supported on some older processors. Like, they basically, instead of going for the newest and best thing that would have basically only been supported on like the latest processors, they went for like the middle ground where it was like it wasn't the fastest thing, but it also wasn't supported on some. Well, you could try to support all of them. That's what I've done in my engine. Dude, so this is what I love, having all this stuff just on this PC ready to go. So now that I'm talking about this stuff, I can go in my engine and I can show you you can't do if-def checks because you want to compile one executable, or at least if you're like me, you'll want to compile one executable for all the different processors. To do if-def checks, you would need to compile a different processor for SSE and AVX and non-SSE. If you look at what I do here, if audio use SSE 4.1, it does the SSE instructions. If not, it does it without SSE instructions. Oh yeah, if we're talking about optimization too, if you want to optimize code without SSE and AVX, you see how this loop does 4 adds? It multiplies the length by 4 and does 4 adds in the loop instead of doing one loop where it does 1 add. If you break down, this is actually way faster. If you look at the actual assembly generated, it basically saves operations on like the for loop has to do operations for each time it loops, and only doing that. If you think about it with this, it's doing one loop operation, potentially a comparison for each of these adds, but for this one, it's doing 4 adds for each of these comparisons. So if you get it, you can basically change the ratio and lower the overhead of the for loop. That's runtime overhead, yeah, it is. But it's just a Boolean comparison. And if you're so the only time I use SSE instructions are for big loops like this. So having just one if statement before a loop looping through 1,000 numbers is insanely small. It doesn't matter at all. Anyways, that'll be the stream for now. I don't know if I'm going to stream tonight. Might stream some Borderlands or something. Either way, I'll see you tomorrow for another programming stream. You know, be doing a lot more programming streams, as you've probably seen. Is there a way to check this at runtime? Look up CPU ID. It's an instruction that is very complicated. CPU ID and times86 operator, the processor supplementary instruction allowing the software to discover the details of the processor. Processor can use CPU ID to determine the processor type and whether features such as MMX/SSE are implemented. Yeah, so you might have remembered before, I was talking about encrypting programs and doing DRM. This is how you'd encrypt a program based off a specific processor. Imagine if you used CPU ID as like a hashing key. You could basically hash something based off someone's processor. Anyways, oh my god, I just keep going. This is why I love programming streams. It's literally something that I can just talk about, and it's like something that never ends. So, oh man, I gotta go though. I will see you around. Thank you for watching. Have a good day. I'll be on Discord too if you have any more questions about this stuff. See you around.